Hello, everyone. Thanks for joining us from wherever you are. Perhaps it's the kitchen table, living room sofa, home office, but wherever you are, we are delighted to speak with you on today's topic, introducing the Yubico Mobile SDK for Android 2.0. My name is Luke Walker, and I'm with the Yubico Developer Program, and I'd also like to introduce to you my colleague Dane Nielsen, Director of Yubico Engineering.
Hey everyone.
Before we dive into this presentation, I'd like to cover several housekeeping items. If you have a question at any time during the webinar, please use the Ask a Question tab located below the player. Your question will be addressed during the Q&A session, which is at the end of the presentation. If you have any technical difficulties, click Support for Viewers at the bottom of the page for troubleshooting help. And finally, please take a moment to rate this webinar at the end of the presentation. We'd like to hear your feedback by using the Rate This tab. The recorded version of this presentation will be available using the same URL shortly following the conclusion, so you can replay it or share it with your colleagues. Today we'll be giving a high-level overview of the mobile SDK for Android, its use cases, and touch on some of the high-level getting started concepts such as transports, interfaces, and connections and how they relate to one another. You can find links to the SDK and other resources in the description if you'd like to take a deeper dive into any of the topics we're discussing today. And then Dane will be giving us a hands-on demo showing us how to integrate the SDK.
And in the demo portion, I'll be showing you how we can modify an existing app to add YubiKey support. The source code for that will be available. You'll be able to view it and try it out for yourself. If you do want to follow along at home, you'll need Android Studio, a YubiKey with NFC and PIV support, and our YubiKey Manager software. Again, we'll provide links for everything you need below.
All right, let's get started. So when we look at how some of our customers are using our mobile SDK, it's all around protecting employees and users and their data. So you can see some of the most common use cases here. Multi-factor authentication for identity and access management, securing VPN access to on-prem resources, providing that second factor for password managers, doing the time-based OTP, and also keeping customer data safe. So here you can see some of the protocols that are matched with these use cases. WebAuthn, PIV, and OTP are pretty popular for application login. Password managers, it's FIDO2 and OTP, and remote access is PIV and OTP, or one-time passwords. And what's nice is that the YubiKey gives the user, or their identity, a consistent experience across applications, whether it's they're logging into a web app, or they're opening up a password manager, or they're trying to get to on-premise resources. So that kind of segues nicely into all the different protocols that this one key supports. It could be a smart card. It can do time-based OTP. We have the Yubico OTP protocol, which just outputs, it acts like a keyboard and outputs a one-time password. It has WebAuthn and FIDO2 as well as OpenPGP. And we find that a lot of customers use multiple protocols depending on the use case and the various systems that they have in place in their environment. So just want to give you a quick view of what this seamless authentication experience can look like if you were using the SDK. So what I'm showing here is the demo app that comes with the Android SDK, and I'm going to add a new TOTP credential to my YubiKey. So I'm doing this over NFC. and I'm holding the YubiKey on the back of my phone, and it registered the credential successfully. You can see there. And then I'm gonna come back in at a later time, and I'm gonna want to get that time-based OTP. So I'll hold the key on the back of the device again, and you'll see here that the credential gets updated. And so 30 seconds later, I'll hold the key up again to the back of the device, and you'll see the new time-based OTP output there. So this is the power that you can get with the Android SDK, and it's pretty exciting. The main benefits of the Yubico Mobile SDK are to protect user identities. You know, stolen credentials are the #1 security problem, and by using the SDK and YubiKeys, you can have strong two-factor authentication across your ecosystem of devices and services. You can use the SDK and YubiKey to access hardware-backed certificates and perform operations such as encryption and decryption with those certificates stored on the YubiKey. You can give your users a consistent experience. It's the fastest user experience for authentication. You can just enter a PIN or a password, touch or tap your YubiKey, and you're in. And one of the focuses for this next release is developer and integration experience. We want the mobile SDK to be consistent across Android and iOS platforms. So some of the main concepts for the Yubico SDK are, obviously you got the YubiKey devices, could be a 5 series, 4 series, FIP series. You have the transports. This is like USB-A or NFC, Lightning, or USB-C. You got the interfaces, like the USB-C interfaces. It could be OTP, like emulating a keyboard. It could be CCID or a smart card. And also there's the FIDO interface. Then there's connections. So could be a smart card connection to do smart card operations. It could be the FIDO connection or the OTP connection. And when you look at the architecture, each of these applications are running on a YubiKey, like OTP, FIDO, OpenPGP, PIV, and then there's a core layer which handles the interface definitions, the global enums, the protocols which implement the framing to use with connections, common utilities. And then there's also the concept of sessions, right? So that have state. You need to be able, as some of these operations need to be able to make calls and get responses in a sequence, and so there needs to be a state associated with that. Could be, some of the example sessions would be like an oath session, a PIV session, or a management session. And all of this obviously runs on top of a platform, in this case, Android. So when we look at how the Yubico SDK for Android fits into the various architectures of how mobile apps are architected, if we look at, starting at the top, you have some browser-based apps, whether it's a web app or a progressive web app that run in the browser. The Yubico Android SDK doesn't work with those directly, but once you get into that lower layer, like WebView or native, for hybrid apps, web native apps, or native apps, we've had customers integrate with our SDKs across those 3 layers. So now it's time for Dane to give his hands-on demo. Take it away, Dane.
Hey everyone, in this demo we're going to be looking at taking an existing toy Android app, and we're going to be adding the YubiKey SDK to interact with the YubiKey into it. So to start off, I have a little app that I've created here. It's called Secret Notes. It's very simple. There's two different screens. So there's the main screen that shows a list of notes. Right now it's empty, which is why it's completely white. If I click on New, that lets me create a new note. There can be a title and some content. And there's a Save button. Once I save it, it takes me back to the first screen where I now see my note in the list here. And if we look at the source code for this, it's a very basic Android project, mostly boilerplate with a few additions. So there's the activity. The activity takes care of loading and saving these notes to shared preferences. And that's pretty much all it does. There's the view model, which just keeps the notes loaded in memory and exposes them as live data so that we can listen to changes in the notes. Then there's the main fragment, the one you see now, which holds that list. The only thing it really does is observes the note list and makes sure our list here is in sync with it. And lastly, we have the note fragment. This is the one, if I click on the note here again, this is the one that opens up. It has an edit text for the title, which when you start a new note, you can fill that in. When you load an existing one, it's disabled, but it shows the title. And then it has the content edit text, which is modifiable after we save it as well. And then there's a save button, and you can go back as well. So nothing out of the ordinary here. It just handles that save button, saving it with a view model, and the rest is pretty much. Here's the loading of notes. So if we start this giving it an existing note ID, then it will ask the view model for the contents, and it will use the ID as the title, and it will get the content from the view model. So far, this doesn't do anything with a YubiKey at all, and that's what we're going to change now. So our hope here today is that we're going to integrate the mobile SDK. We're going to use the PIV module to communicate with the PIV application on a YubiKey. We're going to pull out a public key from the YubiKey, which we can use to encrypt our notes so that we're not just storing them in plain text on our phone, and then also use our YubiKey to decrypt those notes to view them. So first, we need to set up the YubiKey itself. So to do that, I open up YubiKey Manager. I'm in the PIV part of that. This is a fresh YubiKey. It's a 5C NFC, so we can use it over NFC with our Android device in a minute. And we currently have no certificates loaded, so let's change that. PIV defines a few different certificate slots. We'll be using the key management slot, which is, they can all be used for this, but this one's intended to be used for decrypting things. So we'll generate a new key in that slot together with a self-signed certificate. We will be using RSA 2048 for this. And the rest I'm just going to leave as default because we don't really care very much about the certificate itself. I have all the defaults set, so the default management key, the default pin, which is 1, 2, 3, 4, 5, 6. All right, now that key is being generated on my YubiKey. And a certificate was signed by that key and imported into that same slot. So the only reason we need the certificate is to be able to pull the public key out of it. And now that we've set up the YubiKey, let me close YubiKey Manager, and I'll just pull the YubiKey out of my computer as well. Now we are back in Android Studio. We're going to look at the build Gradle file for my app, and we're going to add the dependencies we need. So first up, we need the Android module, which contains all the Android-specific code, some dialogues that we're going to be using, and various other things to make things easier on Android. but we're also going to include the PIV module since we're going to be talking to the PIV application on the YubiKey. So we add those two, and let's now go into the first part of this, which is going to be getting the public key from the YubiKey. So we only want to have to do that once. So we want to, once we have the public key, we can use that to encrypt notes. We can use the same public key after we exit and re-enter the application. So we're going to want to save that. So we're going to do a similar thing to what we do with the notes here. So we create a new preference key for that. And we need a variable for it. So let's actually start by that. In the view model, we'll create a variable there. It'll be a public key. This is a standard Java type. And we'll initialize that with null. That's the thing we're going to pull from the YubiKey, but first, assuming we've somehow done that, we want to be able to save it. We'll create a method for that. Similar to how we save notes, we will check the public key variable, and actually only if it's set to something other than null, we'll execute this. We'll get our shared preferences. So we want to edit that. We'll store the public key. We have to serialize it somehow, so we'll use a string. Use that key. This is the wrong type, and we're going to fix that in a minute. I just want to make sure that we don't forget to apply this once it's done. So we have a public key object. We want to store it, serialize it as a string. So what can we do? Well, we can do toString, but that's not going to be the right representation. We can do encoded. So we get the encoded bytes for it. Now we have a byte array, and if we then base 64 those bytes, we'll have a string. So we get the encoded bytes, and we base 64 those bytes, and then we store them as a string in our shared preferences. Let's see, where do we want to do that? We want to do that anytime we pause the application. So we'll do save public key there. And of course, we need to also load the key. So we'll get the preferences, get the string, and we'll do a default value of null there. And here, we'll make sure to only run this if there was a value stored. So if we haven't saved a public key, we skip over everything. But if there was a public key, we want to load it. Now we have a string here. It's base 64 encoded. So we need to start by decoding it. That gives us the raw key bytes that we need. And now we need to load that as a public key object. And the way to do that in Java is we need a KeyFactory. Let's see, KF of the right type, which is RSA in our case. We need a key spec, which in this case is an X509 encoded key spec, taking those raw bytes. And now our KeyFactory should be able to load that spec and return a public key. So we'll stick that in the view model. There we go. And we need to call this method, so we'll do that right here. All right, So this takes care of once we close the app and open it again to keep that public key. So we only have to get it once. Now we actually do need to have to get it, so let's implement that. We'll put that in the note fragment, but let's keep things neat and tidy by introducing a new package here. We can call it PIV. So I mentioned that the Android module from the Yubico SDK adds a few dialogues. We'll be using one of those. It's an activity that shows up as a dialogue and prompts the user for their Yubico, and then once it gets the Yubico, it will do some stuff with it. There's a few different ways of launching activities and getting results from them in Android, and the way we're going to do that now is through a component that's in the Android Jetpack set of libraries, and that means we need to create a contract for what that looks like. We'll call it PIV get public key contract. Should do this fine. And we'll extend a class which is called activity result contract. This takes input and output. The input is the argument to this this request, which is going to be which public key we want to pull out. We will define that by its slot. So this is one of the PIV classes here. We can take a quick look here. There's a bunch of, it's an enum, and there's a bunch of different key slots that can be used. So key management is the one we used when generating our key, and that's the one we're going to be using throughout this demo. So we're going to tell it we want a public key from this slot, and it's going to return a public key for us. And since you can cancel that as a user, we'll make sure that's nullable. And that needs to be there. And now we need to implement the members of this this class. So one is CreateIntent, which creates the intent used to launch the activity. One is Parse the result, which gets the result from the intent and returns what we want, which is a public key. So we'll start here. This should return an intent. And as I said, we already have an activity for this. That activity also provides us with a factory method to create an intent. And it's called Yubico prompt activity dot create intent. So this takes, first off, it takes a context, which we're passed right here, so we can just use that. And then it takes a Yubico prompt action. So we're going to need to implement that, and we can do that here. We'll call it PIV get public key action, which will be a Yubico prompt action, but we'll actually use this Yubico prompt connection action subclass, which does a few more things for us, namely also connects to the Yubico using a specific connection type that we want. So if we're communicating with a PIV application, we need a smart card connection. We pass the class type to the constructor there. And this gives us a method to implement, which is called onYubicoConnection. So the activity here will show the dialog. It will wait for the user to connect their Yubico via USB or NFC. And once it sees that it has a Yubico that's compatible, it will open the connection type we want, and it will invoke onYubico connection with that connection. So basically that's what this part does. We do want to pass a few things to our action, though. So let's start by putting in our action here. And we want to do stuff with that intent before we return it. So we'll do apply. So this creates the intent, but we also want to pass along the slot so our action knows which slot to use. So let's define a an extra here we can use for that. And we'll do put extra using that key, using the slot that we're passed here. And that's the only thing we need to pass to our action. So this gets invoked. We need that slot, so we'll pull it out of the extras that were also passed in this method. Now, since the slot is an enum that is serializable, we can automatically serialize and deserialize it there. We just need to cast it. There we go. This will never be null, and this will never be null. So we have the argument. Now we have our connection. Now we need to do stuff with it. So to do that, we use a PIV Session, which needs a smart card connection. This lets us talk to the PIV application on the YubiKey to do all the different things that it supports. So right now, we want to read out that public key. The public key is stored in that self-signed certificate. So we do get certificate. Get certificate needs a slot. We have that slot. And the certificate, which is a standard Java certificate object, has a bunch of different things that we're not interested in. What we are interested in is the public key of the certificate. So now we have that. Now this this method should return a pair of an int and an intent. The int is the result code for this this action, and let's see, we'll do that. The result here will just be the standard OK result code. And now we need to pass an intent with the data that we want to return. So we'll create a new intent. We don't want it to be empty, so we'll use apply. And here we will, let's see, put extra. So we need another extra. We need an extra for the public key. Now, we can't put the public key object there directly, so we need to serialize it somehow. This sounds familiar. We use encoded. Here we can pass a byte array, so we just get the encoded bytes, and that's enough. This puts us back into parse results, where we get the result code and the intent data. These are the exact things we returned here. So let's do a when result code. If we get an OK, then we want to return the public key. Otherwise, null. Let's do a return statement here. So since we serialized it, we again have to deserialize it. And because we wrote the code for that just a minute ago, we should be able to just reuse that. So the KeyFactory, where we have the bytes. So the bytes should be in the intent. Get byte array extra. And the thing we want to return is the public key. All right, this should always be, if result is OK, then this will definitely not be null. So there we go. Again, the contract says, given a slot, we launch the YubiKey prompt activity using this action with the slot as an extra. The action gets invoked. we get the slot from the extra. We have a connection to the YubiKey, so we use a PIV session to get a certificate. From that, we get the public key. The public key gets encoded to bytes, put in the resulting intent as an extra. Then we get back to parse results, where we get that intent. We pull out and decode the public key again, and return that. So yeah, all of this is because we need to pass data between different activities. You don't have to do this necessarily. You can interact in a single activity, but we won't be showing that in this particular demo. So now we need to use this contract. Let's go into our note fragment. So what I want to do is anytime the note fragment gets opened, if we don't have a public key saved, we should prompt the user for their user keys, for their YubiKey, so that we can get a public key. So first off, let's define a callback. For the contract. And that callback is a public key. So what we want to do with that is store it in the view model. All right. And we need to invoke this somewhere. So what we'll do is in our onViewCreated, let's just do it at the end here. We'll check the view model for a public key. And if that is null, then we will launch our public key request here for the key management slot. Okay, let's try rebuilding and running this. Let's see what happens. So we're back in the app here. Looks the same as before, but I'll click on this note. And here we see that dialog. So it's using all the default settings here. Of course, you can customize the strings and the look and feel of this a bit. Yeah, this is what it looks like out of the box. So this should work over both NFC and USB. I'll just use NFC because that's easier. So I'll just tap my YubiKey and then remove it. And there we go. So if everything worked the way we think it should, then it should have read that public key and stored it. So let's actually try. Let's kill the app and let's restart it. Go into our note there, and this time we weren't prompted, so that means that it probably did succeed in storing that public key. Now we have that public key, we also want to use it. So how should we use it? Well, still in our note fragment, we said we wanted to encrypt the contents of notes using this. So let's find that here. We have, when we save, right now we're calling set node on the view model with the title and the content. So let's first pull out this into a variable. And now we'll say that if we have a public key, we want to, and let's make that a variable so it's mutable. If we do have a public key, then we want to encrypt the content. To encrypt the content, we need a cipher. And the type should be RSA. Then we need to initialize the cipher to encrypt, and it needs the public key. And lastly, we can encrypt some input here. Now we want to encrypt the content. The content is a string, and encryption needs bytes, so we will do encode to byte array, which gives us UTF-8 encoded bytes for the string. And the output of that should be the encrypted data. Now, all this is done without the YubiKey because we have the public key, and the public key is all we need to encrypt a note. So we can do this anytime we have a public key. We want to update the content that we're actually writing. Encrypted is bytes, so let's again use base 64 to encode those bytes using default settings. And again, let's try restarting this app. So I will open this note, and now I'll hit save and see if it works. So if we do save, we're back here, and we'll open it again. And now we can see that this is not the message that we initially had there. This is base64 encoded. It's also RSA encrypted. So success. And I should point out here that we're using RSA to encrypt the message. This is typically not what you would do in a production app. You would use symmetric encryption on the message itself, and then you would encrypt the symmetric key using RSA. Since this is just a toy app, we're going to do it this kind of easy way. This does mean that our messages can't be longer than 248 bits, but yeah, that's fine for our purposes. All right, so let's try adding another message just for the fun of it. So now I feel confident putting my secret plans in here. I know that if I click on it, yeah, they're completely unreadable. However, I'd like to be able to read them myself, so let's implement decryption. And that will require the YubiKey, since the private key is in the YubiKey and will never leave it. So we'll do that in a similar way as we did the first part. In fact, similar enough that we can just copy paste a lot of this. But we will create a new contract. And let's see. And a new action here. So make sure to use this action. We'll still need to pass the slot, though we have another argument that we need to pass. We're not going to be using the public key, so get rid of that. So we're going to need a few additional extras. So when calling this contract, we need to specify the slot and the encrypted data to decrypt. And when it returns, we want the decrypted data instead. So what do we need to change? Well, right, so we need to take 2 arguments instead of 1. We can do that using a pair. Still the slot, and then the byte array of encrypted data. And we return the byte array of decrypted data. So that's the thing we get there. So when we create the intent, we'll use the same YubiKey prompt activity, different action. We need to pass it the slot, which is now the first argument of the pair. And we also need to pass the encrypted data, which is the second item of the pair. Parse result doesn't return a public key anymore. It returns a byte array of decrypted data. And we'll get to fixing this in a minute. First, we'll jump over to the action. So again, same type of action, smart card connection is needed. We still read out the slot from the extras, but we also need the encrypted data. We use a new PIV session. We don't need to read out a public key. Instead, what we need to do is decrypt the encrypted data. To do that, however, we need to verify our PIN first. Since I don't want to implement a PIN dialog, I'm just going to hardcode the default value there. So this will only work as long as my PIN is 1, 2, 3, 4, 5, 6. But that's fine for this demo. Once we verify the PIN, that allows us to call decrypt. So decrypt needs a slot. We have the slot. It needs the ciphertext. That's our encrypted variable, and then a cipher which tells it which algorithm to use. Again, we specify RSA. So that gives us our decrypted result. And we return, again, result OK. This time we're passing back the decrypted response, which is our decrypted byte array. That puts us back in parse result. And assuming that's everything's OK, we get the extra called decrypted. And actually, we just return that because that's exactly the thing we want. And there we go. All right, let's move back to our note fragment. So when we opened a note, we saw that it was encrypted. What we want to do is decrypt it. And what we also need to do is show it once it is decrypted. So we'll register another callback here. Call it request decrypt using our new contract that returns a byte array. And we need to show that in our view. So that's the content edit. There we go. So we have the decrypted data here. Although it is encoded to bytes, this was the UTF-8 encoding, so we can just decode to string, which does the inverse of that. Of course, we only want to do this if we were successful and didn't get null here. So let's make sure that's the case. And now we need to invoke this somehow. We'll do it here. So when we're loading the content, which at this point is still encrypted, we can launch this. Let's make this a variable. Note, that's fine. So this takes our input, which is a pair of the slot, which was our key management slot, and the encrypted payload. So that is our note. However, our note is base 64 encoded. So we need to start by base 64 decoding it. And there we go. Hopefully that's it. Let's try running it and see what happens. All right, let's see if we can read our secret plans now. Yep, so we can see the encrypted content in the background, but we've also prompted to connect our YubiKey. Let's try to do that. There we go. It worked. So that's how we decrypt our notes. Now I feel fully safe in putting all my secrets in this app, because I know that the only way to decrypt them is by using this YubiKey. And since the RSA key was generated on the YubiKey, it actually will never leave that YubiKey. So I know that as long as I can keep that YubiKey safe, my notes should be safe. Great, that was the end of the demo that I wanted to show. As I said, this will be available on GitHub, so you can, or maybe I didn't say that, I'm saying that now. This code will be available on GitHub, so you can look at it in more detail at your own pace. Again, this is a toy app. There's not a lot of error handling, but it kind of gets the point across. We've shown how to add the SDK to your project, how to interact with the YubiKey, and hopefully you'll download it and give it a shot yourself. So thanks for watching.
Thank you, Dane. Now we're going to take some questions that were asked during the presentation. If you were unable to type in your question earlier, please feel free to do so now. We've had an active audience today, so we'll try and answer as many as time permits. All right, so first question. Is the Yubico Android 2.0 providing a wrapper for any additions for FIDO2 WebAuthn? The previous version did not.
All right, so that's a good question. Yeah, the previous version did not provide a wrapper. The new version also doesn't. The reason for that is so Google provides their own platform support for the FIDO protocols, which you can use both from a browser and from an app. And we're really encouraging users to use those official APIs to access and use the FIDO functionality. Unfortunately, they are a bit limited, but we're hoping that Google is going to continue to evolve those going forward, and that they'll be enough to handle all the cases that our users want to do. So we always find it's better to use kind of the first-hand built into the platform support than anything that we could either wrap around that or add.
All right. Thank you, Dane. Next question. Can I automatically launch my app when a YubiKey is tapped or inserted?
Yes, you can both do that for NFC and for USB, either both or one or the other. That's something that you have to define in the Android manifest. It might require some specific permissions, but essentially you put that into your activities intent filter, and you can cause it to launch your app on one of those actions.
All right. Can the SDK be used to program keys like the YubiKey manager on a YubiKey?
Yes. So yeah, YubiKey manager is a tool used to configure YubiKey in different ways. Like I showed in the demo, you can use that to generate a certificate or generate a key and import a certificate. All that functionality is also available through the SDK. So yes, you can definitely do all that with the SDK.
Oh, that's pretty cool. Let's see here. Next question. Does the SDK work with all Android versions on all devices?
We target API level 19 and up. Unfortunately, we can't test all devices, but we're trying to not do anything super crazy. So it should work on most devices. You'll need a phone with support for NFC if you want to use the NFC capability. Likewise, for USB, the phone needs to support the USB host APIs, but I think all modern phones do that have USB.
All right. Next question, is the YubiKey required for all functionality?
Good question. I believe so. I'm trying to think if, I mean, yeah, there's probably some maybe utility classes that you could use, but to do anything meaningful with the SDK, I think, yes, you do need to have a YubiKey.
All right. If I use, next question, if I use this SDK to implement my own solution, do I have to implement support for all the YubiKeys applications / connections / protocols, etc.? Dane, are you with us? I think I can't hear Dane, so I think we might be having some technical difficulties.
Hey, can you hear me now?
Yep, there we go.
All right.
You're back.
So I talked for a while, but you probably didn't hear anything. Did you get any of my answer to that question?
I did not. I didn't hear anything. No.
All right. So the SDK for Android is split up into different modules. Each module has its own kind of area of responsibility. Most of them correspond to a specific YubiKey application. You're kind of free to pick and choose between these. So you only need to use the modules that you're interested in. And at least our hope is that the modules implement enough of the functionality that you don't have to worry too much about the technical details. You just have to use the parts that you want.
Oh, great. All right. Next question. Can the SDK be used on the desktop?
Currently, it can't. The way it's structured right now, I would say that most of the functionality is not Android specific. So in the future, it's definitely possible that we might build a desktop backend for it, which would allow you to run it on the desktop. I would encourage you to, if you have a use case where you'd like to use this on desktop, please let us know about it so that we can kind of factor that into our plans going forward, and we can figure out how to best solve your use case.
All right. Here we go. Next question. Where can we check the documentation and download the Yubico Android?
Yeah, hopefully we have some links accompanying this webinar. I'm not sure where you can see the description, but there should be. So we have the source code. It's fully open source. It's on GitHub. I know we just published a blog post on our main website that has the links, so that might be a good place to find it. So this is a new version. It's currently beta 1. There's a tag for beta 1 that you can check out, but that's also what's on master currently. Of course, the tags for the existing stable 1.0 is also available, but that's where we have a lot of the updated documentation. And I think any other relevant links will be either in the description for this webinar or on our in that blog post on our website.
Great, thanks. All right, next question. This looks like it's the last question. Is the SDK free to use, or do I have to register or acquire a license?
All right, so that kind of falls back to what the previous one I answered, that nope, yes, it is free to use. You don't need a license. The SDK is on GitHub. It's open source, licensed under the, I believe it's the Apache public license version 2. Pretty standard open source license. So no, please just use it freely and you can communicate with us on GitHub, open issues, and yeah, let us know.
Perfect. Thank you, Dane, and everyone who attended today's presentation. As Dane mentioned, please go to GitHub, try out the SDK, use GitHub Issues to provide feedback. We really want to hear from you. And please remember to take a minute to rate this webinar. And enjoy the rest of your day.